So, in chemistry, when we talk about the mole, we're not talking about the adorable little rodent, but instead we're talking about a quantity. The mole is a fixed number. In this case, a mole is going to equal 6 times 10 to the 23rd. If you want to be a little more specific, it's actually 6.02 times 10 to the 23rd power, or 6 with 23 zeros after it. It's a very large number. We also call it Avogadro's number, as you saw in the video prefacing this presentation. He was the scientist that first came up with this idea of the quantity being the same. And just like a dozen is always equal to 12, 1 mole is always equal to 6 times 10 to the 23rd. So 1 mole of eggs equals 6 times 10 to the 23rd eggs. 1 mole of cars is 6 times 10 to the 6 times 10 to the 23rd power of cars. Very similar to a dozen. If you think about an omelet made from a dozen or 12 eggs, it would be huge. But if you took a mole of eggs to make an omelet, it would actually cover the surface of the earth 30 times. So it is a ginormous quantity that we're talking about. The reason we have such a big unit, because when we're dealing with atoms and molecules, we're dealing with very tiny pieces of matter. One droplet of water contains over 10 trillion molecules of water. So we have to have a big unit to make it easier to work with mathematically. Now, the mole is a unit that we're going to hear over and over again in chemistry, and the reason is when we do calculations in stoichiometry, we're very concerned with the molar mass. This tells us the number of grams that are in 1 mole of an element or any substance that we're working with. Mass number that we find on the periodic table tells us the molar mass of the element. So in this case, carbon has a mass number of 12.011. So that means 1 mole of carbon atoms would weigh 12.011 grams. And when we talk about molar mass, we use the unit grams per mole, or G/mol. So how many grams per 1 mole of the substance? So if we do a few examples, you'll need your periodic table for this. When we look at nitrogen on the periodic table, it has an atomic number of 7 and a mass number of 14.007. So our molar mass is 14.007, and the unit that we just saw, grams per mole. If we look at titanium on the periodic table, atomic number 22 has a mass number of 47.88. So our molar mass is 47.88 grams per mole. And our last one, sodium, atomic number 11. The mass number is 22.990. So the molar mass is 22.990 grams per mole. Again, these are coming directly from the mass number on the periodic table. But in chemistry, we're not usually dealing with just individual elements. Instead, we're dealing with compounds that are made up of multiple elements. We can use the same idea to calculate the molar mass of a compound. For example, if we look at carbon dioxide, the steps that we're going to follow to calculate the mass of the entire compound is first, we are going to count the number of each atom. So CO2, we know that since C doesn't have a subscript, it means that it's just 1. So there is 1 carbon and 2 oxygens. Next, we look at the atomic mass for each element to get the molar mass. Carbon has a mass number of 12.01, which we can round to 12, and oxygen is 15.999, which we round to 16. Again, these numbers, 12 and 16, come from the periodic table. We multiply the number of atoms by the molar mass. So for carbon, 1 times 12 gives us 12. For oxygen, 2 times 16 gives us 32. And in our last step, we just add these two values together to get 44 grams per mole. So 1 mole of carbon dioxide would weigh 44 grams. Pretend you didn't see that. Our last example, CH4. So again, We start by seeing how many atoms of each element we have. There's no subscript for carbon, so we know that it's going to be 1. Hydrogen has a subscript of 4. Next, we multiply it by the mass number from the periodic table. Carbon is 12.01, which we would round to 12. Sorry for that line. Hydrogen is 4 times 1.008, which we would round to 1. 1 times 12 gives us 12. 4 times 1 gives us 4. We add these together to give us our final answer of 16 grams per mole. Last example, calcium hydroxide. Again, we follow the same rules. I'm going to go ahead and list our elements: calcium, oxygen, and hydrogen. There's no subscript with calcium, so we know it's 1. Since we have a polyatomic atom, the 2 outside the parenthesis gets distributed to each element. So there are 2 oxygens and 2 hydrogens. We go to our periodic table. We see that calcium has a mass of 40, oxygen is 16, hydrogen is 2. We multiply. 1 times 40 gives us 40. 2 times 16 gives us 32. And sorry, this should be 2 times 1, my bad. 2 times 1 gives us 2. Add it all together. 2 plus 2, 4. 74 grams per mole.